Here we go, Math 1. I'm Mr. Trutna from Clovis High School, and today we're going to be talking about 8.1 translations. So as we're going over these notes today, you should be actively taking notes, filling in your notes along with me, and then thinking to yourself, asking yourself questions as we go. Okay, so the first thing we're going to do is we're going to define 5 terms that we're going to be talking about and seeing a lot in this chapter. So the first one is a transformation. So a transformation, a loose definition of it is to change a geometric shape. Okay, so it's going to be, we're going to change a geometric figure. And the figure could be anything. It could be a line, it could be a triangle, it could be a four-sided shape. But what we're going to do is we're going to change a geometric figure to a new position or size or shape. Okay? So when you do a transformation, what you're doing is you're changing a geometric figure. You're changing it to a new position, or you're changing it to a different size, or you're actually changing it to a new shape. Okay? And what we call this a mapping. So when we talk about a transformation, it is a mapping, which means to move a shape. Okay, so what we're going to be doing is to move a figure. So what we're going to be doing is whenever we do a transformation, we're going to be mapping one transformation to another transformation, and we're going to be moving that figure around as we go. Okay, all right, so a preimage, you're going to hear that word a lot. So when we talk about a preimage, the preimage is going to be the original figure. All right, so whenever you see the word preimage, or you're asked what is the preimage, it is going to be the original figure, whatever the original figure is. Okay, and then the image is going to be the resulting figure after a transformation. So it's going to be the resulting figure after a transformation. Okay, a transformation. All right, so then we have a thing which we call rigid motion. All right, so motion means that something's in movement, and if we have rigid motion, this is what rigid motion is. It's a transformation. And remember, a transformation just means to change a geometric figure to a new position. It means to move a figure, or to change its size, or to change its shape. So a rigid motion is a transformation that preserves, okay, that preserves distance between points, and angle measurements. All right, so what we're saying here is that if we do rigid motion, what it does is that it's going to transformation, it's going to move a figure, and when you move it, the distance between the points is going to preserve it. That means it's going to stay the same, and the angle measurements are going to stay the same. Okay, and then we're going to learn about our first transformation. So in this class this year, you're going to learn about 3 different transformations. The first one is called a translation. Okay, so a transformation means to slide a shape. So transformation means to slide a shape. Okay, and to slide a shape. So when we slide a shape, what's going to happen is we're just going to take one shape, and then we're just going to slide it to someplace else on a graph. So translation means to slide a shape. So what we're going to do is we're going to work on translating. We're going to do translations today in class. So what we're going to do is, if you notice, in the very first example, you are given a triangle. This is triangle ZLJ, and we're going to translate it, which means we're going to slide this shape to another spot on the graph, okay? Now when we slide it, we're not going to turn it, we're not going to flip it over, and when we slide it, it's going to preserve the exact same distance. So in other words, however long it is from J to Z will stay the same. However long it is from Z to L will stay the same. And however long it is from J to L, that distance will stay the same, and all the angles will stay the same. So angle J, angle Z, and angle L, they will stay the same. So what we do is this. The first thing you want to do when you do a translation, so this right here is an example of a translation. Okay, and what this is saying is, and the way that you're going to read this is this is saying, you're going to take the original figure, okay? So this right here is the pre-image. So you're going to take whatever the pre-image is, and then it's giving you a rule on how to make the image. And if you notice, what it's saying is you're going to take whatever the x value is, and you're going to add 2 to it, and you're going to take whatever the y value is, and you're going to add 3 to it. So what we do is we take our point J, we take our point Z, and we take our point L, and we're going to mark what the coordinates are of J and Z and L. So you can see J is 1, 2, 3, 4, negative 5, negative 2. J's coordinates are negative 5, negative 2. Z's coordinates are negative 4, 0. And L's coordinates are 0 and negative 3. Okay, and then what we're going to do is we're going to follow this rule of, we're going to take whatever the x value is, and we're going to add 2 to it. Okay, so we're following this rule of x plus 2 comma y plus 3. So we're going to take whatever the x value is, and we're going to add 2 to it, and then we're going to take whatever the y value is and add 3 to it. Okay, so the x value. So if you notice, J's x value is negative 5. So we're going to take negative 5 and we're going to add 2 to it. So that would map it to negative 3. Okay, then we're going to take the y value, which is negative 2 for J. We're going to add 3 to it. So that would be positive 1. And then we're going to plot this point. Negative 3, positive 1. And what this point is going to be is this is going to be J, and then we're going to put this little symbol above it, and the way we read that is J prime. So J prime is going to have the coordinates of negative 3, positive 1. Okay, then we're going to do the same rule. We're going to do the same mapping for Z. So we're going to take the negative 4, the x value, we're going to add 2 to it. Negative 4 plus 2 is negative 2. Okay, then we're going to do the y value. We're going to take the y value, which for Z is 0, and then we're going to add 3 to it. So you could see that Z is going to become negative 2, negative 2, positive 3. So that right there, and we would call that Z prime. Once again, that little symbol means Z prime. And then we're going to do the same for L. So we're going to take L's x value, 0. We're going to add 2 to it. That's going to make 2. Then we're going to take L's y value, negative 3. We're going to add 3 to it, and that would map it to 0. So I would go over 2, up 0, over 2, up 0, and that's where I would put my new L, and we denote the new L as L prime. Okay, and then what we do is we just get out a straight edge, and please use a straight edge, don't just hand sketch it. So we're going to get it out a straight edge, and we're going to connect all the points together, and when we connect them, you notice that my image is exactly like my pre-image, so those two are exactly like each other. It's just that my image has been translated from my pre-image. How has it been translated? It's been moved right 2 spots and then up 3 spots. Okay? All right, so let's do the next one here. We have, notice, we have a new rule. So my new rule is saying for this example, I have triangle FGY. So let's go ahead and let's put the coordinates. So my rule is saying this. I'm going to take my X and my Y value, and then I'm going to map them by, I'm going to add 6 to my X, and then I'm going to subtract 4 from my Y. Okay, so F has coordinates of 1, 2, 3, 4, negative 5, up 4. So F has coordinates of negative 5, 4. G has coordinates of -4 and +2, and then Y has coordinates of -5 and +1. Okay, so what I'm going to do is now I'm going to work out my rule. So my rule says, and with this rule we call a mapping, it says take your x value, which for f is -5, and add 6 to it. So that would mean that becomes 1. Then it says take your y value, for f is +4, subtract 4 from it, that would be 0. So your new image for f, which we call f prime, would now be at over 1 up 0. Okay, so f prime would be at over 1 up 0, and I'm going to mark that right there. And then I'm going to repeat the same rule for g and y. So to find my new coordinates of g, which we're going to call g prime, I'm going to take my x value, -4, add 6 to it, so that'd be 2. Then we take my y value, which is 2, subtract 4 from it, so that'd be -2. So I'm going to plot the point, +2, -2, and that's where my g prime is going to be. And then I'm going to do the same for my y to get my new coordinates of my y value, which would be my image, which we call y prime. Okay, so I'm going to take my -5 of my y, add 6 to it, so that'd be 1. Then I'm going to take my y value, which is 1, subtract 4 from it, so that would be -3. I'm going to plot that point and call it y prime. Over 1, down 3, and you can see that y prime is right here. And then what we do is we connect the points using a straight edge. Okay, use a straight edge to connect the points. Don't just hand draw them. We want to make this as neat as possible. So if you notice, does that shape, which is my image, okay, so this is going to be my image, does it change from my pre-image? The answer is no. So when we talk about does it preserve distance, okay, and are the angle measures the same? Absolutely. So this would be another example of a translation from triangle FGY down to triangle F prime, G prime, Y prime. Okay, the third example right here, we have a four-sided shape, JTME. This four-sided shape really doesn't have a special name to it. Okay, and so we're not going to worry about the name, but you can see that we have a mapping rule. So my mapping rule says that I'm going to take my x value, I'm going to subtract 2 from it, I'm going to take my y value, and then I'm going to add 5 to it. Okay, so the first thing that I'm going to do is I'm going to mark the coordinates of point J, point T, point M, and point E. And then I'm going to follow the rule, which is subtract 2 from x and add 5 from your y value. So you can see that J's coordinates are -1, -2, -3, -2. So J has an ordered pair of -3, -2. T has an ordered pair of 0, -1. M has an ordered pair of +1, +2, +3, -2. So M would be 3, -2, and then E has coordinates of -1, then down 1, 2, 3, 4, 5. So -1 and -5. Okay, so we're going to use our rule, our mapping rule. All right, and this is going to be a translation. So what does that mean? It means that we're going to slide the shape. Okay, so to find my new J coordinates, and when we find our new J coordinates, this is going to be our image. We're going to call that point J prime. So what are we going to do? Well, we're going to take the x value, which is -3, and then we're going to subtract 2 from it. So that would get me to -5. Then I'm going to take the y value, which is -2, and I'm going to add 5 to it. So that would get me to +3. So the image of J, which we call J prime, would have coordinates of -5, +3. 1, 2, 3, 4, 5. 1, 2, 3. So there's my J prime is going to be right here. And then I'm going to follow that same rule for T and M and E. Okay, so the new coordinates of T, which is going to be the image, which we'll call T prime, we're going to take the x value, 0, subtract 2 from it. So that would get me to -2. And then we're going to take the y value, -1, add 5 to it, so that would move that to 4. So the image of T, which we call T prime, would be at -2, +4. So T prime is right up here in quadrant 2. Okay, you can see I slid J to J prime, I slid T to T prime. I'm doing a slide, which is called a translation. Following the same rule for M, M prime, which would be the image of M, would be 3 minus 2, which is 1, and negative 2 plus 5, which is 3. So I would go over 1, up 3, and that's where M prime would be. Okay, and then the last one, I would have my new coordinates for E prime, and E prime would be negative 1 minus 2, which is negative 3, then negative 5 plus 5, which is 0. So I would go over 3, up 0, and that's where my E prime would be. So you could see my new image, which we actually call the image. Remember, the pre-image is the original shape. Your new shape is your image, and if we did it right, the new shape should be exactly the same as the pre-image. It should just be moved to another place, and you can see that these two shapes map onto each other. So if I took this original shape, the pre-image, remember the original shape is called the pre-image, and I moved it, I slid it, and the fancy name for sliding is a translation. Translation means to slide a shape. This shape would slide exactly onto my image. Okay, all right, moving on. We're almost done. We got a couple more examples to go here. So we got one more example of a four-sided shape. You can see that my rule for this one is I'm going to add 4 to whatever my x value is, and then I'm going to add 3 to whatever my y value is. Okay, so I have point C. Point C's coordinates are negative 3, positive 1. Point J's coordinates are 0, positive 1. Point K's coordinates are positive 1, negative 1, 2, 3, negative 4. So positive 1, negative 4. And then point M's coordinates are 1, 2, negative 4, negative 2. Okay, so I'm going to then map, so I'm going to move each one of these points, and I'm going to follow this rule right here, adding 4 to the x, adding 3 to the y, and I'm going to create new ordered pairs for each one of my points right here, and then the ordered pairs are going to be called C prime, J prime, K prime, and M prime. Okay, these are going to be my image to my pre-image, which is right here. All right, so how do I do that? Well, I'm going to take, for C, I'm going to take its x value, negative 3, add 4 to it. That would be 1. Then I'm going to take C's y value, 1, add 3 to it. That would be 4. I'm going to plot that point. Over 1, up 1, 2, 3, 4. So right here, that's where my C prime is going to be. That's my image of C. Then I'm going to do the same for J. So I'm going to take J's x value, 0, add 4 to it, 4. Take J's y value, 1, add 3 to it, 4. I'm going to plot the point over 4, 1, 2, 3, 4, up 1, 2, 3, 4, and this is where J prime is going to be. Okay, take K, 1 plus 4 gives me 5. Negative 4 plus 3 gives me negative 1. So I'm going to go over 1, 2, 3, 4, 5, down 1, and that's where K prime is going to be at. And lastly for M, to map it to M prime, I'm going to take negative 4, add 4 to it, that's 0. Take 2, add 3 to it, that's 5. So M prime is going to be over 0 and up 5. Okay? Wait, that doesn't seem right, does it? Oh, because M, someone should have caught me. Naali, why didn't you catch that? Yuriana, I can't believe that. M's coordinates are negative 4, negative 2. So I'm going to take negative 2 and add 3 to it, so that's going to be 1. So M prime is going to be over 0, up 1, which is actually right where J is. So that's going to be M prime right there. I can't believe that right there. Come on, Kai, get with it. Follow along. Sometimes I make decisions that are wrong on purpose there. Just see if you guys are paying attention. Wake up and smell the math for a little bit. All right, so that would be my new image right here. C prime, J prime, K prime, N prime. Is that image the exact same shape of the pre-image? The answer is yes. How did I get it? I slid the pre-image up to the image. So what's that called? When you slide a shape, what's that called? On three. 1, 2, 3. Translation! Yeah, you're right. Good job. Okay, all right. Last two examples here. The next one, we're going to do a translation. So it's telling us we're going to do a translation. What does the word translation mean? It means to slide a shape. So we're going to slide a shape, okay? We're going to slide it 7 units to the right and 1 unit down. Now, how do I show that, okay? So what that means is I'm going to take my x and my y value. I'm going to slide it 7 units to the right, so that would be x plus 7. And I'm going to slide it 1 unit down. How would I represent moving this 1 unit down? Exactly, y minus 1. Alyssa Pena, great job there. Okay, so, but I don't have a shape here, so what the heck do I do? What? What'd you say, Kirsten? Oh, you plot the point, J, F, and N. Great job. Okay, so I'm going to plot the point J. -3, +1. So there's J. I plot the point F. -2, +3. There's the point F. I plot the point N. -2, 0. So that's the point N right there. When you plot the points, label them. And then connect the points one to the other. All right, and you're going to get a triangle. What would we call this triangle? NJF, or any order you want here. Okay, so now what am I going to do? Well, I'm going to move each one of these points 7 units to the right and 1 unit down. Okay, so watch what I'm going to do. I'm going to start point N. I'm going to move it 7 units to the right. Tell me when to stop. 1, 2, 3, 4. Trevor, that was 4. Don't say stop. 5, 6, 7, and then I'm going to move it 1 unit down. Boom, right there. What's that point? N. What do we call the image of an N prime? Great job. I'm going to do the same for F. 1, 2, 3, 4, 5, 6, 7 units to the right. 1 unit down. Stop. Put a point. That's the image for F. So that is F prime. I'm going to do the same for J. 1, 2, 3, 4, 5, 6, 7. Move it 1 unit down. So that point right there is going to be the image for J. What do we call it? J prime. Okay, am I done? No. What do I have to do? I have to connect the points. Connor, are you going to connect the points just by drawing some sloppy line? No, you're going to connect them with a straight edge. So you connect the points with a straight edge here. All right, and then there we have our translation. Okay, now I have a question. What's that blue shape called? Is that the image or the pre-image? That is the image. Good. This is the image. The red shape is called the pre-image, okay? And what did I do to move the pre-image to the image? What's that called? It's called a translation. What does the word translation mean? It means I slid the shape, to slide the shape. Okay, last one. We're going to do another translation. So once again, what does the word translation mean to do? It means we're going to slide the shape. We're going to go 6 units right and 3 units down. Okay, so how would I represent that as a mapping? Well, that means I'm going to take my x and my y value, and then I'm going to move it. I'm going to move it 6 units to the right. So how would I represent that? Good, x plus 6. And then I would move it 3 units down. Lauren Linford, how would you represent that? Y minus 3. Excellent job, Lauren. Okay, so now I'm going to take my shape. Well, once again, I don't have my shape. So I have to plot my shape first. Okay, so I'm going to plot S, which is -3, +3. That's where S is going to go. C is -1, +4. That's where C is going to go right there. Do you guys agree? There and there. Ryan Christensen, are we good so far? Good. Stop talking. Emily Caldwell, sit down. Okay, and then Elise, we still have to do point W, which is -2, -1. So that would be right there, point W. Connect the points. Okay, and you're going to make a triangle. Triangle WSC. Okay, once again, connect them using a straight edge. Connor, don't just try to hand draw them. When it does, then you look like, doesn't look good at all. We want to make this look professional. So now I'm going to do a translation. So I'm going to slide each one of these points, 6 units to the right and 3 units down. Okay, so I'm going to start at W. I'm going to count 6 units to the right and 3 units down. So tell me when to stop. 1, 2, 3, 4. Trevor, that was 4. Don't say stop yet. Let's do it again. 6 units to the right. 1, 2, 3, 4, 5, 6. Now I have to go 3 units down. 1, 2, 3. Ashlyn writes, do you think that's right? That's where W. What do we call that, guys? Good. W prime. Okay, then we're going to do the same for S. 6 units to the right, 3 units down. 1, 2, 3, 4, 5, 6. 1, 2, 3. S just got moved to that point, so we call that S prime. That's the image of S. C, same thing. 1, 2, 3, 4, 5, 6. Then 3 units down. 1, 2, 3. And that's where the image of C, so we call that C prime. Then we just connect the dots using a straight edge here. Alyssa Yarbrough, use a straight edge. If you don't have a straight edge, go to the front of the class, right underneath the TV, to the left of the TV, and grab a ruler. Okay, or just use your ID card. Okay, so there we go. So look at the two shapes. Do they look exactly the same? So did the distance from W prime to S prime, is it the same as W to S? Sure looks like it. How about W to C and W prime to C prime? Yep. How about S to C and S prime to C prime? Yep. So was distance preserved? Absolutely. Did each angle stay the same? Is C's angle the same as C prime's? Yes, it is. Same with W prime and angle W. Same with angle S and angle SW. So that means this image is a translation of this pre-image. Okay? All right, pick up the worksheet, get to work, ask questions, and we'll see you next time.